So the last piece of this vision and graphics segment is I'm delighted to have Jerry Chen from Wayfair here. Of course, Wayfair has been doing some really interesting work in AR, the ability to use your smartphone and pick something from the Wayfair catalog and see it in your own room. So it seemed like a very nice fit for the work that you've just heard described. So Jerry Chen is a senior data scientist and statistician at Wayfair in Boston. His training is in biological sciences. He has an interesting interdisciplinary training, biological sciences, molecular and integrative physiology, and statistics. He enjoys solving biological problems using quantitative approaches, and you're going to hear more about that in today's Wayfair Industry Spotlight.
Good morning, everyone. Today I would like to talk about Wayfair's marketing data science project. As one of the biggest online retailer in home furnishing and home decor, every year Wayfair spends thousands of millions of dollars in different types of advertisement. So as data scientists, we help to optimize this approach by optimizing the budget allocation as well as maximize return on investment of the different marketing channels. As of myself, I'm focused on this specific marketing channel called paid search or search engine marketing, where we develop automated algorithms to bid in real time, so that every time a customer is searching for something on Google or on Microsoft Bing, Wayfair's ads will show up. And if the customer clicks the ads, we have to pay a cost to Google. And later, if the customer decides to buy, we will always have revenue from that purchase. So our goal is to maximize net revenue as long as the revenue is sufficient to compensate for cost. So naturally, this is an optimization problem. Our goal is to maximize revenue subject to revenue minus cost is non-negative. Our current solution has two steps. First, we build up time series models to predict future revenue and cost based on the historical performance. Next, we plug in those predicted values into this empirical function to make bid adjustment. This approach has been shown in the past 2 years working pretty well at Wayfair, but certainly there are rooms for improvement. One of the missing pieces that we never used so far is we didn't consider the relationship between bid adjustment and its consequence, which is the revenue and the cost change. So in our next generation of bidding automation tool, we decided to model the relationship of revenue and cost as a function of all the causality. Further, we use ensemble machine learning techniques to characterize this relationship. On the right-hand side, I'm showing this backtesting accuracy results. Basically, the red one is our ensemble model. You can see it improved and stabilized the accuracy when compared to any of the blue individual models. Once we have this predictive model, it is relatively straightforward for us to just optimize our bid values. We do this for two scenarios. If we notice a keyword is profitable, we search the bid value range and maximize that to bring in more revenue. On the other hand, if a keyword is non-profitable, we search for the keyword, we search for the bid value such that we minimize our loss. So we launched this A/B test to compare our new model against our baseline model, and clearly the new model is bringing in more traffic and more revenue. At Wayfair, we make our decisions based on data and evidence. Therefore, A/B tests always serve as our gold standard. One of the other important projects we have at Data Science Marketing is this automated A/B test platform, where we care about two things. We would like to have control type 1 error. Meanwhile, we would like to maximize statistical power such that we can always detect any signal. So for the interest of time, I'll skip the details for this project. Basically, we leverage both machine learning and biostatistical modeling to achieve those two goals. Here's a bigger picture of data science at Wayfair. I work for the data science marketing team. We care about bringing in more customers to our website. We also have data science product team. Their focus is helping improving the experience of the customers once they come to our website. Two typical problems they solve is they use reinforcement learning to serve recommendation nowadays. Meanwhile, we also have this new visual search tool based on deep learning. So nowadays, if you're interested in some furniture, you can just take a photo and search in our database. We also have data science merchandising operation team. They are more back-end team. They work closely with merchandising. A lot of their projects is about natural language processing. They try to extract useful information from our suppliers' description of their products. For those who are interested in computer vision today, we also have a post, so feel free to come visit our poster later. Thank you for your attention.